Meteorological Society. So Dr. Robinson, please take it away.
Uh, Kendra, thanks very much, and good morning, everyone. Thanks for joining us this morning. Hopefully, you'll come out of this with some credits. I guess I have a captive audience. You have to stay till the end. But beyond that, I want to tell you something about our state's weather and climate, and how it is changing, and of course, talk about some of the ramifications of that for public health. Um, I don't need to tell you folks a lot about that. You've been telling me how weather and climate and change associated with that are affecting your jobs, your positions, what you're seeing out there. And I hear that from the agricultural community, emergency management communities, environmental protection, and so on and so forth. But today, specifically interested in public health, and we'll get to that towards the end of the presentation when we talk impacts. So you've heard enough about me already. Let's move on. Here's what we're going to talk about. Just tell you a little bit about the State Climate Office to kick things off. Then a little on New Jersey's weather and climate change, and then get into the impacts, particularly focused on human health. Um, but anyway, greetings from the Office of the New Jersey State Climatologist. Many of you hopefully knew there was such an entity. We are situated at Rutgers via gubernatorial decree back in the 1970s, and we have been at Rutgers ever since. It's a small group of people, including an assistant state climatologist and some IT staff and some field staff as well. And we also have student interns all the time helping us out. We're here to help you folks answer questions that have to do with decisions you have to make out there. Our credo of sorts of all state climate offices is local trusting locals. We have wonderful relationships with regional and national climate entities, but when it comes to our individual state, in this case, the Great Garden State, um, we have the local knowledge. I'm born and raised in Jersey. So I've lived Jersey weather and climate since a little kid, and I've loved it since I was a little kid. But we bring the information, the data, and the expertise to help you make decisions. We don't make them for you, but we'll provide the background weather and climate information to help you make those decisions. And we invite you to visit our website, njclimate.org. I'll tell you in a minute about our weather network that Kendra kindly mentioned. But you can start on this page, but there's a lot of information packed in there. We always invite you to contact us, and we can help walk you through that information processing and help you with your decision making. I mentioned the weather network, the Rutgers, New Jersey Weather Network. We've got 69 stations situated around the state from High Point Monument to West Cape May, Liberty Science Center in Jersey City out to Rutgers Snyder Farm out in western out in Hunterdon County, excuse me. We gather data of a multitude of weather variables from these stations every 5 minutes, and it immediately is put onto maps and tables. And each station has its individual web page that's accessible, no charges, no login, anything, but to anyone at any time. Here you see some thumbnails of maps I grabbed off our lead web page, njweather.org, yesterday afternoon. And you can click on those and zoom in and click on stations within it. And there's the New Brunswick. We have a station at Rutgers Gardens, one of our 69 stations, and it includes a lot of information on current weather, the past 24 hours. You can dive back in it for months and months and years earlier. We've been active for about 25 years, give or take. Some of our stations are as new as a year or two old. Some go back 25 years or so. And then we have a forecast there on the left side. That's the National Weather Service's forecast. We don't make weather forecasts. We leave that to our meteorologic colleagues at the National Weather Service or in atmospheric science program at Rutgers, for instance. And of course, in the private sector, there are a number of private weather entities. We just provide the information. Our weather network data gets fed into National Weather Service forecast models for the US. And there's a number of these, what we call mesonets around the country. So it's used in real time, but it's also used to archive what's happened in the weather and climate of our state, of our region on a pretty high resolution going back decades. We also have a volunteer network, CocoRAS, that Kendra mentioned, Community Collaborative Rain, Hail, and Snow Network. We have over 300 volunteers, wonderful citizen scientists who purchase a standard rain gauge, you see there on the left, and a ruler to measure snow. It's a national program. Our office manages the Jersey portion of that program. And it's a wonderful way of filling in the blanks. Our automated weather stations can't cover everywhere. With 300 more observations, we can really keep our finger on the weather and climate of our state. So, invite anyone who wishes to join in. There's all kinds of tutorials online, and you can get active pretty darn quick. Another thing we do is, again, provide useful products beyond just our weather network that are available. This product's used, particularly the figure on the left, used by the Department of Environmental Protection all the time as we monitor drought. The left figure is the last 12 months of precipitation departures statewide based on multiple dozens of stations. The red bars are below normal precipitation months. The bigger the bar, the greater the negative precipitation anomaly. And those departures are based on averages from 1991 to 2020. But we also have data going back to 1895. And when we rank them going back 131 years to 1895. And if they make the top 10, we annotate them on the figure for the season or the month. And for instance, on the left, you can see our drought that really began in earnest last September with the third driest September on record. Then we pitched a shutout, hardly any rain. Not only was it the driest October on record, it was the driest of any month on record going back to 1895 in New Jersey. A couple hundredths of an inch of rain was it. And that drought continued, as you can see, until we had a saving grace of a wet May, which kept us out of drought restrictions and watering restrictions this past summer. And that was followed by a dry June, a little above normal in July. Some areas got deluged in July locally, but overall the state was a little above normal. And then we went dry again in August. And I might add, we're working on some preliminary values. We're going to be an inch, I don't think quite 2 inches below normal. So it's going to look more like the June bar there for September. So this is our second consecutive dry month across the state, particularly the northern half of the state. A little bit better off in the southern half. Whereas last year, the drought really began in the southern half of the state and then moved into the northern half. On the right are temperature departures, red bars above normal each of the last 12 months, the blue bars below normal. And you can see we had 3 colder than normal winter months last year. Quite unusual. It had been several decades since we had seen that. But then along came March, which was the 10th warmest. And then look at the beginning of summer. You had the 9th warmest June, the 6th warmest July. But then the saving grace to the summer was we had the coolest August in New Jersey since 1994. That brought the 3-month summer period, June, July, and August, to the 16th warmest on record. Almost all the top 20 have been just within the last couple of decades. We'll talk more about that in a minute. But again, services we can provide to you, you health officials who need some retrospective look at what's been going on out there. Moving on, you folks all know we have a wide variety of weather and climate in the state. That's why I love it. I'd be bored if it was snow all the time, even though I study it globally, or it was warm all the time. Not for me. I love having four seasons, but with that, we have beautiful weather as we've had the last couple of days, but we're also faced with extremes at times. You can see examples here of snow, flooding, top center, up in northern part of Barnegat Bay from Sandy, a tornado on the top right, strongest tornado in New Jersey in over 30 years with Ida back in 2021, down in Gloucester County, flooding from Ida in the lower right in Manville in Somerset County, but that looked just like Floyd in 99 and Irene in 2011 and Ida in 2021. Um, you may remember the Jones Road fire of this past April, which threatened and mercifully avoided residential areas on the eastern side of the Pinelands and closed the Garden State Parkway for a time. We are fire prone, particularly in the Pinelands when things get dry. Speaking of dry, the lower left is an August cornfield back in a drought, a summery drought in 2010. We didn't get hit that hard this year, thanks to that wet May and pretty good rains in July. So we're better off. And the top left is, somebody remember November 15th, 2018, when it wasn't a huge snowstorm, but 5 inches of snow fell in a couple hours on a Thursday afternoon. Everyone headed home, and we had multiple hours of gridlock on almost every road in the state. So sometimes it's not a matter of how extreme the conditions are, it can be the timing of that. If this snow had fallen on a Sunday morning, no one would ever remember those 5 inches of snow, but it was the timing of that. So when we're talking about impacts on human health and threats to human safety, sometimes it's a matter of timing, not just a matter of magnitude. Anyway, moving on. We have multiple zones around the state. For a small state, we have the maritime influences along the coast. We have the hills that impact our climate to the northwest. The aforementioned pinelands in the green there, which are dry out very quickly with its sandy soils and become a fire threat. The southwest part of the state tends to be the warmest area, lower elevation. It's away from the cooling influences of the water, a little further south. And then that tweener zone, I call it, the yellow area, where you have localized urban heat island effects because you have the highest population density there. You have more impervious surfaces there, which increases the threat of flash flooding. Sometimes it can behave like the northwest part of the state, sometimes more the southern part. So we have a variety of climate regions across the state. Now, what about this climate change? I'm not going to harp on that here, but we have to address that issue because, as it says here, it's happening now and it is affecting New Jersey. Um, and let's cut to the chase. Why is it happening? Because humans are having a significant influence on the global environment, local and global, I might add. That's why I'm so confident. And I'm confident not just because, oh, it's getting warmer. There's more observations than that, both regionally and globally. More extreme rainfall events. Yes, warmer in all seasons. Sea level is rising. We look up to the Arctic, we see sea ice declining. We see the Greenland ice sheet losing a lot more water off of its melting than is being accumulating on that ice sheet due to snow falling on the ice sheet and becoming part of the ice sheet. We see it in the tropics with the bleaching of coral reefs because sea surface temperatures are rising a degree or two, and that's all it needs in a more stable climate of the tropics to create havoc. So we're seeing a lot of observations suggesting that climate is changing and that humans are playing a role in that. We also have theory, which I'll explain. I'll show you a couple slides on this in a moment. Greenhouse theory. So this is basic physics that support the fact that humans are having an impact on this change. And then we have numerical climate models, sophisticated computer models, even looking at AI now with some of these climate models, that all suggest that the climate would not be changing like it's changing now without human influences. And it's also our crystal ball into the future because you can keep changing how humans are impacting the climate and how some natural variability joins in with that. And that's where we can start making projections into the future and how things are going to look in the coming decades, the remaining part of the century, and so on. So let's look first at a couple more observations. This is a time series of New Jersey's annual temperatures based on several dozen stations going back to 1895 on the left, 2024, our latest full year on the right. The blue line is what we call linear regression. It goes back to about 1980, where most climatologists really feel that the human signal of climate change began to emerge from the noisy natural variability we get with year to year climate change, as you can see the ups and downs here. But look at how the pace of warming has increased in the last 40 or so years. A cooler year in recent decades is as warm as the warmest years were in the first 3 quarters or more of the 20th century. And you can see the number of record years we've had, near record years. We can still have a cool year here and there. There is still that natural variability within the climate system. But overall, we have extreme examples of warming over the past several decades. Precipitation-wise, you see an awful lot of interannual variability. You can see the mega drought of the mid-1960s, but you can also see the two wettest years in the last 130, 31 years have been in 2018 and 2012. So we had a drought at the turn of the century for a period of time. Then we had some wet years, some dry years. It bounces back and forth, but overall, there's a general increase in precipitation. But what's really interesting about this is the variability of precipitation from year to year has become much more pronounced than it was in the earlier middle part of the 20th century. So we have to be prepared for deluges and drought. And the other thing you don't see, but it's embedded in these numbers, is that more of our rain is falling in larger events. I like to say when it rains, it pours. And that's associated with the fact that a warmer atmosphere has the potential of holding more water vapor. For every 1.8 degrees Fahrenheit of warming, the atmosphere can potentially hold 7% more moisture. So we're warming at that pace. So the availability of moisture is there. When a trigger comes, you can get very heavy rainfall in a short period of time. But if the trigger is not there, it's warmer, and warmth, evaporates things, dries things out faster. So that's why we can flip-flop between drought and deluge in a more rapid pace than in the past because of our warming climate and the potential availability of more moisture in our atmosphere, often tapped from our offshore warming waters. So we've created quite a more extreme situation that we've seen evidence of in the last several decades with some really tumultuous extremes in precipitation, for instance. theory is this greenhouse theory. We have a natural atmosphere over us, and it helps to hold some of the solar radiation that comes in through the atmosphere and warms the surface. It's harder to get that heat out. It's like putting a blanket on the bed. And that's natural. And that keeps the earth habitable. It permits water to remain in liquid, vapor, and frozen form. If not for that atmosphere, the sun only gives us enough energy to keep us at about 0 degrees Fahrenheit. But think of it as a body on the bed. In the case of the bed, it's your heat coming off your body. And with a blanket, it takes a longer period of time for that heat to leave you than if there was not a blanket there. But eventually it leaves the top of that blanket. Otherwise, you self-combust, right? So it slows down the loss of heat from your body. In this case, it slows down the loss of heat from solar energy that's absorbed by the Earth's surface. So it stands to reason if you increase the blanket coverage. If you're cold, you put another blanket on the bed. If your human activities add carbon dioxide and methane, these greenhouse gases that help to hold that warmth in, they're the blanket. If they hold it, if they increase from their natural quantities, and there is natural methane, there is natural carbon dioxide and water vapor, which is not, it's the most pervasive greenhouse gas. We're putting another blanket on the bed. By warming the atmosphere, it can contain more water vapor. We're warming the atmosphere because we're increasing burning fossil fuels and increasing carbon dioxide. We're doing animal husbandry and things like growing rice, which emits methane, which is a very potent greenhouse gas. So there we are when it comes to physical theory, the actual physics of it. And then finally, we have these models, which again are very sophisticated global models run on some of the world's fastest computers. We'll see where the AI age takes us here. But this is how we model how the atmosphere works. It's used in weather forecasting. It's just run on different time scales to look at back and ahead to our future climate. So what about the future climate? We see evidence quite clear that greenhouse gases continue to increase. Oceans are warming, atmosphere is warming. Temperatures are going to continue to rise. New Jersey's warming at a faster pace than most states. There may be some urban influence there, but mainly I think it's, and this is areas being studied, we have warming oceans and we are a maritime state. You don't have to go too, even you go off to Sussex County, you're not that far from this large ocean off to your east. And that's helping to amplify the warming in New Jersey. So rising temperatures, essentially, I have to say it's a take to the bank. At the pace of the rise, we can talk about a little later. Um, for the mid-Atlantic states, increasing precipitation or at least steady precipitation. Some globally everywhere essentially is going to continue warming. Precipitation is more a regional or zonal impact. Dry areas tending to get drier. Moist areas like ours tending to get wetter. Polar regions where it's so cold you can't hold much moisture in the atmosphere. As they warm, they'll have more moisture being able to be retained in the atmosphere, so they'll get wetter. But it's not just how much in a year, it's pointing toward, models point towards our cool seasons getting wetter, but not necessarily our warm seasons. So that can be a threat for drought, for instance, in the summers. But it could also be a threat with moisture conditions in warmer winters and springs and falls, leading to more vector problems with infestations and molds and things like that. More variability. Yes, more storms and floods, and yes, more drought. As I explained, it's a much more volatile climate system than it was in the past, prone to these fluctuations and extremes. This isn't a cop-out where climatologists throw about just everything in there. There's good physical reasoning and observational evidence that this variability in these extremes are already here and are destined to get more extreme, worse in the future. And then finally, we haven't talked much about it, but being a coastal state, we've seen sea level rise of 1.5 feet over the last century for a variety of reasons we don't have time to get into here. But the pace of that sea level rise is expected to increase by mid-century and the second half of this century, such that we might have a lot of models suggest a 3 foot rise in sea level by the end of this century from what it was here in the first couple decades of this century. There'll be an updated report on that coming out later this year through a project I've been involved with Rutgers, some other universities in the state, and the New Jersey Department of Environmental Protection. It'll be the third version. The latest was 2019. This will be a 2025 or early 2026 update on projections of sea level rise for the remainder of this century. Temperature-wise, it's hard to know exactly how warm it's going to get, and that's partially due to you and me. It depends on how we treat our environment. If we let greenhouse gas emissions run amok into the future, that red bar you can see there on the right part of the figure will likely be the range of temperature changes. The green bar is if we get our emissions under control, we go greener with renewable resources of one sort or another. So you can see up to the middle part of the century, there's not much of a difference. The die has kind of been cast, whether we go actively to ameliorate the situation or let things run ahead. But what we do now is going to make a difference in the second half of the century. So we control the fate of the second half of the century right now and in the years ahead. The greener we get, the less chance of the extreme levels of warming that are projected. So warming, yes, but how much? It's going to depend on what we do now in terms of controlling our emission of greenhouse gases. Moving on now to the impacts, and I see we're doing okay here because I'll be covering these in the next 10 minutes or so, and then we'll have some time for questions. I hope you have. First of all, a general figure showing you all the impacts, or some of the impacts, not all the impacts are out there, from changes in temperature, precipitation, and yes, sea level. And taking it from the bottom to the top, you can see things that DEP is interested in, and geological survey and people who live along the coast, coastal impacts, species, natural variability, all being impacted already by changes in our weather and climate. Certainly water resources. We seem to be going into these flash droughts, but then we can pull out of them with some heavy rain, and that becomes a real managerial task for the public and private water entities, purveyors in the state. Fresh water is a finite resource. New Jersey's not built a new reservoir since the mid-1980s, and there's none on the drawing board. So we have to know how to better manage our water resources than ever before, using less water and saving water as best we can without getting into having to find it elsewhere. Desalinization is very expensive, for instance. You look at the water oceans next to us, but it is cost prohibitive at this point. I don't want to see it become not cost prohibitive unless technology brings us there, because the other threat would be if we're running out of fresh water, we're going to have to pay those extra expenses. But any case, water resources, forest impacts. We have invasive species that can winter over now, that the southern pine beetle is hitting our Pinelands region. In the past, our winter, coldest of cold winter nights were cold enough that the eggs of that invasive species couldn't winter over. So we were okay. But now the coldest of cold winter nights are warming at a pretty good pace, and that's allowing this invasive species to occupy our forests. It's just one example. Agriculture, you're concerned about the growing season, about infestations, invasive species and such that could ravage our crops. And then finally, the health impacts. And let's turn to those. I found a number of these different figures. There's so many different ones out there. A lot, though, are versions of this particular figure where you start in the middle with climate change writ large, rising temperatures, weather extremes, drought, flood, heat, um, extreme variability, and then rising sea level if you happen to be a coastal state, obviously, in particular, particularly areas that are threatened by being low-lying nations. We're focusing on Jersey today. We often think about the United States, but this is a global issue. And there are areas that are already very vulnerable to low sea level for extreme storms and such that not only are being threatened by more extremes in the weather, but also rising sea levels that threaten their very landscape. And those tend to be the areas that are less affluent in parts of the globe. So we see that in New Jersey, but we also see it globally. So the next circling out from the core there, you see just a whole variety of impacts that you folks maybe pick out those that you're most familiar with. And then the manifestations, the impacts of severe weather on injuries and fatalities, or waterborne diseases on cholera and other health threats. So you've got a whole variety of these just covering so many different dimensions. And I realize some of you have to deal with a multitude of these. Others may be focused on one or the other. And some may be things you don't necessarily always think about unless you've been involved with situations of late, looking at mental health, for instance, with the anxiety, depression, post-traumatic stress. I know of people who have been flooded on multiple occasions, and they hear that heavy rain on their roof, and it brings a heightened level of stress. So we can't forget any of these. And oftentimes, one thing I haven't talked about, it's not just one extreme. It could be the repetitive nature of these extremes that I just mentioned, but it can also be the compound effects. You get a hurricane impacting you, and it impacts the power grid. And that's followed, because oftentimes hurricanes are warm season events, by a heat wave. So that's what I mean by a compound event. One thing that makes people more susceptible to a second type of event. I often, I don't know, smile about this, but shake my head when it comes to Sandy on the 29th of October back in 2012. And you didn't have heat following that event, but with power outages, you had some cold weather following that. And about 10 days, 2 weeks after that, we had a snowstorm, an early season snowstorm that brought Monmouth County 10 inches of snow, which was on top of all the debris left from the impacts of Sandy. So there was a very strange one where you had a tropical event followed by cold, as opposed to tropic followed by heat. But think about these compound events that make bad situations considerably worse. So a bunch of wordy slides here, kind of to finish up on things. But if there's one take-home figure you might catch your attention today, I would say it's this one. But let's look at heat increasing. Again, look at those who are most vulnerable. I've given many an interview on this. It's the young, it's the elderly, it's the infirmed, And it's those who don't have means of cooling readily available, generally those are less affluent. The symptoms, it's not just those people, because in some cases, I know people that say, oh, it's been hot and humid. I went out for a run in the middle of the day just to see what it feels like. No common sense. But even more importantly, your construction workers, your police officers, your farm working communities, people who are healthy, but still when exposed for long periods of time to the heat and the stress of heat and humidity can be just as affected and impacted as those listed above as the most vulnerable. Urban areas are more vulnerable because they are warming at a little faster pace due to pavement and rooftops and air conditioners blasting out heat um, out into the environment around there. So we have urban areas getting warmer, reduced air quality with more heat, warmth, stagnation. It can lead to reduced air quality. We'll get to that again in just a second. I wanted to bring this to your attention because, it's the old, it ain't just the heat, it's the humidity. And this is a temperature humidity index of such. And there's all different indices, and there's things now called wet bulb temperatures that are getting a lot of attention for outside activities because it brings in solar radiation and wind speed along with humidity and temperature. But you can see the impacts of the feel of that heat, the stress on the body, as with increasing humidity, your body has a more difficult time ridding itself of heat through perspiration because that perspiration won't evaporate. And the evaporation process removes heat from your body. So you warm things up um, and increase the humidity. You increase the health threat significantly. Urban heat. This just gives you a little cross section of temperatures, how urban areas tend to be warmer than park-like suburban or ex-urban areas. On the left, the y-axis, you can see late afternoon temperature differences with temperatures up in the low 90s in the urban areas. But if I was to show you a figure at night, it would be cooler, yes, but more pronounced would be the difference between the urban and the rural areas because it's very difficult to cool off the macadam, the rooftops, the sides of buildings, turn off air conditioning at night. So it's the urban areas at night are considerably warmer than rural areas. And that leads to the inability to catch a break, not only for the human body to cool off a little bit at night. Urban areas, that's extremely difficult, but it also puts a continued 24-hour stress on air conditioning, for instance, that could lead to more failures. So it's not just the daytime heating that is a problem in urban areas. It's the nighttime warmth as well. And let's not forget, I had to throw in something here. I talked to the horse groups in Jersey last year, and we were talking about the impacts on horses. These would be your home pets. We can't forget about them as well. So I had to throw something in to keep an eye on our pets. Um, but then you may say, it still can get cold. It still can get cold. It's just that the probability of extreme cold is shrinking as the probability of extreme warmth increases. But we can still be cold. I mentioned last winter, we had 3 consecutive months of below normal temperatures. And within those months, we had some very cold weather. So we still have to be aware of that. But what I think is interesting to consider is as we are used to more warmth in our seasons, we're less prepared for the cold. And that can lead to problems. It's a known fact that the morbidity rates are higher when you, for instance, at the beginning of the summer season in the early heat waves, because we aren't yet prepared for them. The same thing can apply to the cold. So we have to still be aware that we can have cold weather. And again, that can impact those most vulnerable in terms of affluence and in terms of age and health. So we can't forget we're in New Jersey. We haven't gotten any further from the North Pole. Um, but overall, yes, we're seeing the extreme cold less often, but it still has the potential of impacting us. And we might be less prepared as we become a little more complacent to the cold weather, more, I won't say comfortable, but more commonly see the milder weather. Um, Extreme weather. We've always dealt with extreme weather. We just seem to be dealing with extremes becoming a little more extreme, perhaps extremes becoming more frequent. Although when we studying of hurricanes, right now the state of the art is there won't be an increase in hurricanes in the future, but the storms may be stronger, they may amplify more quickly, and being here in the middle latitudes, they may maintain their strength coming out of the tropics for a longer period of time. So not necessarily more, but those individual storms potentially more extreme. And with that, all sorts of impacts on human health, availability of food, communication issues, access to healthcare, a big problem. Post-event, as people put on their generators, if they're a fossil fuel powered, a gasoline generator producing carbon monoxide. Sandy's an example of that. There were lives lost days after Sandy due to accidents and this carbon monoxide poisoning. That's a huge problem after freezing rain events that can knock out power. Jersey doesn't have as much freezing rain as some parts of the country, but there's some suggestion we might have more in the future as we flirt with the freezing line during our winter storms. And with that, there are oftentimes carbon monoxide poisonings more common in the winter as people try to heat their homes with the loss of power due to an ice storm. And then we talked about mental health, depression, and PDS, post-traumatic stress disorders. Um, I realize this is a really depressing presentation in some respects, but it's something I know you folks deal with far more than me and are far more aware of. And that includes the spread of diseases, be they foodborne, waterborne, animal-borne, the tick concerns, Lyme disease, West Nile viruses, things we've seen increase the seasonality of those events increasing due to warmer falls. Look what it's been the last week. The last week was 7 degrees above normal in New Jersey. What had been an average to a little cooler than average month is now going to come out a little above average. We see longer seasons of these. We see invasive species that we've already alluded to coming into play. Um, we have the vectors. Again, I'm getting a little repetitive here. These slides are going to be available. That's why I wanted to include these slides. I tend to not like a lot of wordy slides, so I'm going to move through them pretty quickly here. We're getting towards the end. Um, Drought. You may not think of drought as an extreme, but it affects the limited water resources, food resources, and it can affect diseases along the way. It's not healthy, let's just say. And then wildfire, which is part of drought. And we certainly have seen in recent years with fires across the globe getting more attention with smoke invasions, both aloft, as we saw this summer, kind of out of harm's way most of the time towards respiratory issues. And what we saw just several years ago with the Canadian wildfires just totally choking our skies with smoke there in that early June, particularly that early June scenario several years ago. So that's just for speaking Jersey. Um, and then again, associated air pollution we've alluded to with heat waves, we've alluded to with wildfires. We can talk about more in the way of ozone, the lower atmospheric ozone, which is unhealthy, as opposed to this stratospheric ozone up above jet level, which helps to filter out ultraviolet radiation, which in turn protects us from um, different problems with our eyes, problems with skin cancer and such. Our stratospheric ozone over New Jersey has not changed markedly. That still has been more of a problem over colder climates, particularly in the southern hemisphere down the Antarctic. But it is something we have to keep an eye on, although we've kind of arrested that somewhat with the reduction in chlorofluorocarbons, which ate that ozone in the stratosphere. Our ozone concerns in New Jersey are more tropospheric or lower atmosphere ozone with the respiratory impacts. Um, and that's the ground level ozone. I forgot I had this next slide coming in here. So what do we do? Mitigation efforts. Don't have a lot of time to get into that, but they're costly, they're challenging. Um, Reducing carbon dioxide emissions from the energy sector is a challenge, as we all know. Whether it's politically charged or not, it's challenging. Promotion of renewable energy, we've seen the ups and downs of that. Um, there's an interesting article I don't know, it was in the Post or Times I read this morning about the use of solar energy in Southern California, the ideal house and whatever for that. Um, so we don't have time to get into that, but some things we need to consider as we sum up. We have a wide variety of weather and climate. Makes New Jersey interesting, but also can be difficult and challenging. And the climate is changing, which is increasing those challenges. The climate change is likely to accelerate into the future with more extremes, quite likely. The impacts, as we've noted, many cases here, lie within the public health spectrum. Those are likely to expand and become more noteworthy. And then finally, to leave on a bit of a positive note, we talked about some mitigative things in the last slide. We were smart enough to get ourselves into this mess by starting the combustion engine and things like that. I'd like to think there's enough human ingenuity out there to deal with address some mitigative or adaptive actions that will help us be able to address, attenuate, and cope with our climate change and our extreme change in weather extremes. So with that, I had to stop on a nice note, an area of shot I took from up in the Great Swamp, an area that was destined in the 1960s to potentially be the next jet port in this area, but was saved due to conservation efforts by the public and by even political spectrum and save this great swamp. So I'll leave you with that and be happy to take some questions. Kendra, if you have some.
Thank you so much, Dr. Robinson. That was really, really great. Yes, we do have some questions and comments in the chat. First, we have someone that said, hello to Dr. David Robinson. My son, Rohan Jain, was your student and proudly working with NWS in North Carolina. The topic is very close to our family heart. Thanks for this session and congratulations on your professional.
Best to you, best Rohan. I do remember. I've been at Rutgers since '88, so I don't think I have grandchildren of students I had back then yet, but I certainly have um, the children of some of my earlier students. So it's just wonderful to hear from them.
Yes, very nice. All right. So is there anyone studying the effect climate change is having specifically on young children in New Jersey?
I'm more familiar with some studies being done with the elderly from our public health sector here at Rutgers. I've been working with them. Um, I can't quote chapter and verse of studies being done. I would hope there are some out there because, as mentioned, they are vulnerable. I particularly worry about heat when it comes comes to the young. They just don't have the ability, as if I need to tell you folks, their thermostats don't operate as well as those that are healthier and of older age, not necessarily old age where the thermostat stops working again. Um, but there is active research being done at Rutgers and elsewhere addressing health issues, health challenges.
Great, thank you. Can you talk a little bit about the state's subsidence and the relationship to our drought?
The state.
Subsidence and the relationship to our drought.
Okay. Well, I think of subsidence in two ways. I thought you were getting into sea level. I started as a geologist. I have geology degrees, and the land is subsiding because we're pumping water out of the ground, and it's still subsiding due to post-glacial effects 20,000 years ago. But the subsidence with drought, I think you might be referring to with this question, is that we get our storms when the air rises and it brings moisture up through the atmosphere that cools and condenses, forms clouds, forms precipitation, and down it comes. But when you have high pressure, a ridge of high pressure, fair weather over you, the air subsides. And as the air subsides, it warms and dries. So that's where you start getting drought situations when you have perpetual high pressure over the area, just like we had last fall into the winter. So that's something we look at on weather maps all the time. Subsidence in the atmosphere. It also has an impact on the hurricane season. We expected an active Atlantic tropical season this year, and it hasn't been all that active because subsidence has been a little bit more frequent in the Atlantic basin than was projected. There's a couple other reasons, African dust and other things like that. I remind you, Sandy certainly reminded us, the tropical season is not over yet. We've had mostly what we call fish storms this year. Humberto's out there now as a big one, and was Erin before that, and I always lose track of all the storms. But we've been very fortunate, not just in New Jersey, but around the southeastern US. Fortunate in the sense of not a severe storm, but unfortunate in the sense we've had no remnant tropical moisture make it up here to keep things wet. So, the good and the bad. It's great that we haven't had a major storm, but it's bad that we haven't had any moisture come from tropical, well-behaved tropical disturbances moisten our environment here in Jersey.
Great, thank you. What can individuals do to help, and what can we encourage the community around us to do to help?
You know, it's a concerted effort on everyone's part. And the difficult part about this is I can see people sitting and going, what I do isn't going to make a hill of beans a difference. Well, what you do, if 9.3 million New Jersey residents did, that would start helping out. And then you start bringing it globally. So you have to think in that multiplicative side of things, that what I do can make a difference in my life. And if everyone pitches in, it can make a tremendous difference in everyone's lives. And that's, you know, using cleaner energy. And it's not just using cleaner energy, it's using less energy if you can. Um, make your house or your apartment or wherever you might live more energy efficient. Insulation. Turn the thermostat up in the summer and down in the winter as best you can be comfortable. Um, you know, think about it when you drive, and the car you drive and how often you drive. And there's all of these different things one can be involved with. And also one can be exercise their right, the democratic right at the voting booth. And if this is a passion to you, look at the platforms of the candidates. And if it's an important one to you, vote accordingly. I'm not telling you how to vote. I've stayed as apolitical in my career as state climatologist with multiple governors. I've worked with and advised multiple ones from different sides of the aisles. But I'm just saying, you have that right. So that's one way of doing it, but you can also do it in your everyday life as well.
That's great. Thank you for that. Are there general suggestions you might make to those who work in public health as to how they can better educate the public about these important climate changes, or anything else they can do to help mitigate the impacts of climate changes in their communities?
I thank you so much for bringing up that question. This is one thing it's really been, I've harped on a lot in a lot of presentations and a lot of work I've done in recent years, and that's communication. You said, how are we going to communicate and educate our folks? We can be the sharpest scientists with the most data and the best ideas and the best projections. But if we don't share that, we don't communicate with public health officials and others, and sometimes with the general public, what good is it going to do? And I feel very strongly about that, particularly when it comes to hazardous weather events. You need to know what's going to happen, explain it to those who, whether it's in the media or emergency management, who can get the word out. Then the public has to be able to hear that word. And then finally, the public has to know how to act upon that. Shelter in place, evacuate, one or the other, and so on and so forth. So communication is so important. So I would say, as public health officials, just be out there and try to engage your public as often and as best you can without overwhelming them with the science, giving them practical ways of dealing with this, things they can do in their everyday life, things they can afford. And but it all comes down to communication, getting the word out, and getting the public to listen and act upon your recommendations.
Thank you. That was great. So it's 12 o'clock. We have just one more question. Um, and maybe I can send the others to you if you have time to answer them. I feel like on an individual level, the change I notice most is not temperature or humidity, but more severe wind. Can you comment on wind changes, or if it just seems to be the biggest change to me?
Yeah, that's a good one. I get asked that. Boy, I tell you, the first half of this year, I was asked that an awful lot because we had a very windy first half of 2025. And I've had this in every year, it seems. It's getting windier. We've had a couple students look at this. And the trouble is, we don't have real long-term databases. It's mostly at airports, and they even move the anemometers, the wind sensors at the airports over time. But we looked at Newark Airport, for instance. It's open area. And we found no trend in increasing winds, both of the extreme variety and of just the average variety. But we need to dive into this more. And now with our Rutgers Weather Network, where we have stations all over the state, we're starting to get long enough records, 10 and 20 plus years, that we can start looking at this in a little more depth so I can be less evasive when I'm asked a question like this. But at this point, really no large trend in increasing wind.
Great. Well, Dr. Robinson, this was great. Thank you so much. I mean, I honestly believe that this is some great information that we all needed to hear, given the type of weather we had in the beginning of the year and the summer, flooding and heat and all of that. So I did share the slides with everyone in the chat, but I will share the slides again via email as mentioned. For those who are still on, I'm going to share the evaluation link. And again, I will share this evaluation link at the end, just in case anyone has any issues with trying to get access to the evaluation. But Dr. Robinson, thank you so much for your time. We really appreciate this presentation and the information that you provided. And you don't have to stay on. I'm going to wait around for everyone to get access to this link. But thank you again.
Thank you for inviting me, and thank you everyone for taking the time out of your day to hear me out.
Thank you.
Take
Take
care.
care. So hi, everyone. I will stay on for a few minutes, but again, I will share the evaluation link and the slides in a separate email. Just remember that this program, we're only offering public health and health education credits.